This video is just to clarify a topic, and that is for exponent rules that you can only add or subtract powers if they're exactly the same. So for instance, if I have x to the power of 5 plus x to the power of 2, I can't simplify that any further. I cannot do, okay, 5 plus 2 is 7, so it must be x to the power of 7. It does not equal x to the power of 7. You cannot add those unless they're exactly the same, and they're not. They're different powers. That means the base has to be the same and the exponent has to be the same. The base and exponent must be the same. So for a different example, if I had x to the power of 6 plus x to the power of 6, now they're the same power. Because remember, this whole thing, the base with the exponent, is a power. So since they're the same, I can simplify it further. So it becomes, well, there's an imaginary 1 in front of this one, and there's an imaginary 1 in front of that one. So 1 plus 1 is, I've got 2 x's to the power of 6. 2x to the power of 6. Another example. What if I have 3b to the power of 2 minus 2b to the power of 2? So the first thing you want to check is, are the powers the same? And yes, they are. They're both b to the power of 2. So then you look at the coefficients in front of them. I've got 3 minus 2 of those powers. So that's 3 minus 2 is 1b squared, which can also just be written as b squared. We don't have to write the ones. Okay, so when it's adding or subtracting, the powers must be the same. I'll do one more example with you. What if we have a fraction? What if we have 2 over 5 plus 2 over 5. Let's change it up a little bit. Let's make this cubed and cubed on the left. Right now the powers are not the same, right? But if I put an exponent of 3 on this, now it'll be the same. It doesn't look like it yet, but when you apply that exponent into both parts, everything inside the brackets, this becomes 2 to the power of 3 over 5 to the power of 3 plus 2 to the power of 3 over 5 to the power of 3. So now these are equal. They're the same power. This and this are the same. They both have an imaginary 1 in front. So in total, there's 2 of them. There's 2 to the power of 3 over 5 to the power of 3. I put the brackets there just so you know there's 2 of that power. So it's actually multiplying. When you, what's the word I'm looking for? If you want to evaluate this, okay, if you want to evaluate this, you can start by evaluating what's inside the brackets. So 2 to the power of 3, 2 times 2 is 4, 4 times 2 is 8. 5 to the power of 3 is 5 times 5 is 25, times 5 is 125. Then, the rule here for multiplying is there's an imaginary 1 over any coefficient. So when you're multiplying, you can multiply the tops, the numerators, and you can multiply the denominators. So this becomes 2 times 8 over 1 times 25 is still 125. So this becomes 16 over 125. And I can't simplify that any further, I don't think, because 125 ends in a 5, so it can only be divided by 5s, most likely. And 16 can be divided by 2, it can be divided by 4. So I could check it out. 125 can't be divided by 2 or 4 without getting a remainder. So this is my final answer. This is evaluated. Okay, And if I was asked to give my answer as a single, or simplify my answer as a single power, simplified as a single power, then the best answer for that would be, let's look back at what we had. This is close, so we're going to update it. It would be 2 and then 2 over 5 to the power of 3, because we only want one power. So that single power is 2 over 5 to the power of 3. And then there's a 2 in front of it because there's 2 of them. So just to recap one last time, the only time you can add or subtract powers is if the power is exactly the same.